Good morning, everyone, and welcome to another online event organized by EHPA. I am Irene Geasai, and today we're here to get to know and celebrate 4 projects that basically promote heat pump excellence. Of course, I'm talking about the 4 winners of the Heat Pump City of the Year Award 2020 edition, now known as Heat Pump Award. So before we get into the super interesting presentations, I would like to, of course, talk a bit about the Heat Pump Award. So the Heat Pump Award is an EHP project that started in 2011 that aims at recognizing the most efficient, smart, and sustainable heat pump projects at a local level. It's, as I said, it started in 2011. And we have just closed our 2021 edition. And like here on the screen, I hope that you can see like the pictures, the graphic recording of the winners of this edition that we have just closed, the 2021. We have received, since we started, so as I said, 2011, 202 applications, so submissions, 202 different projects coming from 149 cities, from 35 different countries in Europe and beyond. So as you can see, lots. As I said, we have just closed the 2021 edition, but now we have just, I would like to announce that the 2022 edition is open. So in case you're interested to participate, or to get to know better, like the Heat Pump Award, in case you're not familiar, I invite you to scan the QR code that you have on the screen. And just get to know better. Of course, you can also ask me personally. I will share my details in a follow-up email from this event. So now let's get started with what we came to do here. So as I said before, today we will be presenting 4 great projects, examples of heat pump applications. And after these 4 projects, project presentations, we will have 30 minutes Q&A. Therefore, if you have any questions, I encourage you to write them on the chat, which you can find in the bar below. And please, if you are directing it to a certain speaker, just add the name. So like this, we know who is it directed to. So now, without further ado, I would like to introduce the first speaker of today, who will present the Heat Pump City of the Year winning project. And his name is Patrick Berry. And Patrick is the technical director of Together Net Zero. And that's part of Together Housing Group. He's the responsible for Together's housing carbon reduction strategy and approach to energy management and investment. And as of today, unless he corrects me, he's in charge of managing a carbon reduction investment project with the long-term aim of making Together Housing a net zero business. And now, 1 second, Patrick, in a second, you'll see your presentation on the screen. There you have it, and the floor is yours.
Lovely, thanks, Irene. Good morning, everybody. Here to talk about our project, which won the award. And this is a large-scale project to install shared loop ground source heat pump systems in domestic properties and specifically in social housing. If you could go to the next slide, Irene. So Together Housing, a bit of a strategic overview. Together Housing is a social housing provider in the UK, one of the largest in the north of England. So we have 37,000 properties which we own and manage across the north of England. And we have established a carbon reduction strategy and hope to achieve net zero by one way or another in the next generation. So we're talking around 2040. I've not been specific about that. Now, with that many houses, a key to us achieving that is the electrification of heat, and this key part of the decarbonisation process. When you consider that 31,000 of our 37,000 properties currently have gas heating and hot water, that is a major challenge for us in terms of how we transition. And so we see heat pumps as central to that, and moving away from fossil fuels directly in our properties. And we want to be able to use heat pumps in a way which does three things really. One, it provides direct benefits for the tenants in our properties who tend to be on lower incomes and in a particularly challenging time with energy costs at the moment, where we can get measurable reductions in carbon, particularly as the grid itself decarbonizes, and where it works for us as a business, as a piece of investment and a piece of long-term property management. Next slide, please, Irene. Now, there's a number of ways of looking at this, and it wasn't just driven by the carbon agenda. There's a quite a strong tenant focus on this. Um, we have, and this particular project was focused mainly on flats and apartments across our properties, and in those, fuel poverty has been a concern, mainly because the majority of properties we're talking about had electric night storage heating. So these are effectively heaters filled with bricks that heat up during the night at lower rates of electricity cost and release the heat during the day. Um, by and large, these are very disliked by our tenants. They're difficult to use, often expensive to run because people don't understand them properly, um, and often when you do need them most in cold weather, they run out of heat during the day. So we had lots of people lobbying for a change. We also have a number of tower blocks that have gas heating in them, um, and that gas heating system has become obsolete and we can't replace it. But also, since the Grenfell fire disaster in the UK in the tower block, gas is seen as certainly unsafe to have in tower blocks, and so we're looking to replace those. And that becomes a slightly different challenge. So we were looking to find a solution that provides both reliable comfort and is economic to run for our tenants. So certainly providing cost savings compared to the other systems. And after a lot of research, the shared loop ground source heat pump was the solution we chose, and we did that because whilst there is a shared array that sits under the ground, taking the benefit of the heat that's there, each individual property has its own heat pump, and so they pay for their own electricity. There's no involvement from our side in terms of meter readings or having to collect cash from tenants in a different way for energy costs. So although this is a communal system, it's also totally independent for each user. Next slide, please, Zoe. From a business point of view, we had found a lot of our properties where they have night storage heating. We have higher rates of turnover. Um, Tenants don't like them, as I mentioned before. There are higher fuel costs, and ultimately, if a tenant has a choice between keeping warm and paying their rent, they may well not pay their rent because it's harder to deal with that from our point of view. Um, this was brand new when we started it, and this was nearly 3 years ago now. And we started off with a pilot scheme in two 8-story blocks in Halifax, in Yorkshire, 124 flats, mainly occupied by older people. And we wanted to test both the process of installing these, but how that impacted upon the tenants, because this is a big piece of engineering and takes quite a long time and is quite invasive into the properties. But we wanted to, again, see if we could deliver what we talked about in terms of our objectives for the tenants, in terms of whole home comfort heating, um, which is centrally programmable from an easy to use programmer. Next slide. So we've been doing this for about 2.5 years, and our target is to deliver 954 properties. And we've done that in properties that have ranged from 2 stories to 17 stories, with boreholes that go up to 200 meters deep on site. And so this has been a major organisational, logistical challenge both for ourselves and for the tenants involved. But by and large, that's been a very successful one. So I'd like to take you now a little bit through the method that we employed to deliver this. Next slide, please, Aaron. So what was very useful in terms of, again, and thinking about the newness of this particular project when we started, we were able to use a procurement hub called Procure Plus, who helped us actually with the
I am afraid we have lost Patrick.
fairly quickly.
Patrick, we have missed like few seconds of your presentation. I think it was disconnected from your side, maybe internet connection. Just
Okay,
let you know.
just start again at this slide.
Okay, perfect.
Okay, so we procured the services of Kenza Contracting and Kenza Heat Pumps. They specialise in ground source heat pumps, and in particular in a heat pump called the Shoebox, which is able to fit neatly into individual apartments and operates quietly and is easy to use for the tenant. We used an existing procurement site from Procure Plus, where pre-qualified heat pump providers and contractors were already in place. And very important for this project is we utilised an incentive from the UK government called the Renewable Heat Incentive and some other funding for poor performing properties, but it's the renewable heat incentives that's been absolutely central to what we have done and enabled us to look at this in a very financially sustainable way. We treated each individual site as separate because they're all very different in terms of the system design and operation. And we were able to effectively praise that financially before moving forward. Heavy involvement in terms of tenant consultation because they have to get used to the drilling that's going to take place outside, the fact that we're going to have to fit a wet system into properties where there's previously just been the electric system. And this involves quite a bit of disruption, often with older tenants. So it needs very careful handling. And in the past 2.5 to 3 years, we've now installed 771 properties, and we just have 3 tower blocks to complete in Blackburn in Lancashire. And it's important to I think recognise when we launched this project in certainly in 2019, this made up about 10% of the domestic ground source heat pump market in the UK. So this was a big thing and showed a major confidence in the technology, which we wanted to have an impact, particularly on the social housing sector. Next slide, please, Ari. So, having installed these systems, we have achieved what we wanted in terms of increased comfort. Again, for mainly older people, improvements in health and well-being, the whole house heating solution. We found that previously with the electric heating, rather than using storage heating, they'd go out and buy a plug-in radiator, which they'd use during the day and only to heat one room. So big improvements there. We monitored the smart meter data over the course of 12 months in a sample of the properties, and we found up to 45% savings on running costs compared to the night storage heating, which in 2019 was equivalent to around £400. Those numbers will have gone up now, particularly in recent months. And obviously significant improvements in control for tenants using the standard off-the-shelf time clock and thermostat. We had to spend quite a lot of time and effort making sure tenants knew how to effectively use the system. and that was both before, during, and also a follow-up visit after to make sure that tenants were comfortable and applying systems correctly. Next slide. Um, I think a big lesson for us was the effort you have to put into managing a project this disruptive on where people are living. We fitted all these systems while tenants were still in the properties, so a lot of noise, a lot of men going around fitting pipes in the buildings, and has to be managed very carefully. Um, and whilst we had one or two issues, by and large, this went very well. Just a number of thank yous we received about the way that was done. And anybody repeating this project, this is pretty fundamental to how it's done and getting the acceptance of the project going forward. Next slide, please. So this is a big project. We've delivered a large volume of domestic conversions to ground source heat pumps. Some of those now have been in for several years. We've had virtually no issues with that. The tenants are very happy with what's been installed from both a comfort and a cost perspective. We've seen reduced tenant turnover and reduction in the empty homes that we have in these sites. These are low service and low maintenance costs. And we also put in place something with our contractors, so they provided on-site training to our own technical teams, both to service and to do the basic installation and removals of heat pumps to enable us to respond to tenants. One of the things about the heat pump we used was if there is a failure on site, rather than have to wait for specialist engineers to come out and try and fix it, the heat pump is very easy to remove from any particular property and replace with a new one. So the heat pump can go away to be fixed, but the tenant doesn't lose heat or hot water while that's happening. The heat pumps we've used have a 20-year life cycle and relatively low replacement costs because the infrastructure remains in the ground for the long term on a shared basis. So uh, this has worked for us, it's worked for the tenant, it's worked for us from a repairs and maintenance perspective, and it's relatively easy for our neighbourhood management staff to be able to hand over properties to new tenants in terms of explaining how to use systems, and that's proved to be very effective. Next slide, please. So why is this project important? I mean, it was a very large project of its type, still is. The UK government has said that we need to be fitting around 600,000 heat pumps a year to be on course for the commitments to achieve net zero by 2050 as a country. At the moment, only about 20,000 heat pumps a year are fitted. There is a rapid increased uptake of that, and that has to happen for us to electrify heating in our domestic properties. We deliberately use this project to promote and show what could be done when planned at scale and to give confidence in the technology, which, although not new, is relatively new to the UK market. And we had at least 80 different social housing providers come and see the project in the UK, look what had been done, and talk to tenants and to help them go on and think about applying the technology in their own systems. So we think we demonstrated that large-scale heat pump retrofit, particularly to flats and apartments, is a viable alternative to fossil fuels. Next slide, please. For the future, as I mentioned already, heat pumps are central to what we want to achieve as part of our decarbonisation. And one of the key things is taking tenants with us on how we do that. So our kind of campaigns around education will be key. People are very used to using gas in the UK, but we also want to be able to use our heat pump investment in different ways. So as with elsewhere, there's a lot of effort going into the balancing of the electricity grid and how that works in the future. And we see the potential to generate revenue from the aggregation of heat pumps and the way that they work with the grid. So, for example, at peak demand times in a major city, if we were able to take several thousand properties off grid during those peak demands, that will not only help balance the grid, but has the potential to generate an additional revenue for us as an organisation to help pay for the costs of installing heat pumps, and particularly ground source heat pumps, into the future. Um, so we believe we've particularly demonstrated how this can be done at scale in social housing, in properties that are from 2 to 17 stories, where they have both electricity and gas, and where that can be both installed and operated successfully and in a sustainable way. Thank you.
Well, thanks a lot, Patrick, for your presentation. It's time we move on to the second presentation of today. Presenting the Decar Building Award-winning project, we have with us today Thomas Bockland. He's the manager of Boydens Engineer, now part of Sweco Consulting Division. And his main role as a manager, let's say, out of, I guess, more things, but is to integrate new research, innovations, and necessary follow-ups into the different projects Boydens Engineering is working on, like including the project that he's about to present today, GAR Maritime. So Thomas, whenever you want, the floor is yours.
Thank you very much. I will share my screen here. Is this okay?
Yes, it's perfect.
Yeah. Okay. Thank you. Okay. So yeah, big welcome from me as well. Thank you for participating. My name is indeed Thomas Bockland, and I'm managing the consulting department. Maybe I'll just add that within Boydens, and that's my next slide right away. Within Boydens, we always aimed and will always continue to aim for making buildings as sustainable as possible. So as Boydens Engineering has been for decades a technical engineering company, we always focus a lot on energy and energy use, but obviously we look at the broader picture as well, as that is definitely required with the buildings we make these days. These are some references we made throughout the years, and as that since 4 months we are now also part of the bigger Sweco group, which will hopefully allow us to make projects of even larger scale or even more projects that are as sustainable as we can, with fossil free as a baseline, with which we mean that we will no longer, unless we absolutely necessarily have to, but we will no longer use gas or diesel as fuels within our buildings. Indeed, today I'm here to talk about the GAR Maritime. I took a picture, an old picture out of the box to show you a bit what we were talking about. The GAR Maritime, for the people who speak some French, it's in the name. The GAR Maritime was a railway station, not for people, but for goods. Mainly goods, as you see here on the picture, so mainly packaged small goods, so no bulk goods. And it was a terminal station in which the goods were delivered to the city of Brussels and were then dispatched throughout the city, or could go onto the waterways that are close by. The building has been used like this for many decades, and I think the last use, I'm not entirely sure, but I think the last use was in the 70s. After that, unfortunately, the building was abandoned and was no longer, well, there was no longer anyone who used the building anymore, so it was in a rather bad state. But at least this picture kind of shows the vibrant working environment that the people had back in the days. Which we will try to recreate somehow. It will no longer be this, but this is a bit dark. I'm sorry about that, but anyway, the railway station is actually part of a large site, the Tour and Taxi site in Brussels. I I don't know if you can see it, but I will go around. So we had all the trains coming this way, and then actually here you had, this is the Gare Maritime, which is the biggest building on the site. In front, people who know Brussels might know the Dépôt Royal, or the Royal Depot. There they had the trains for people, and then here there was also a big site which housed yeah, a railway station outside, so it was not covered. But so the client, our client Extensa, owns the whole site, and the whole site is now being developed into a you know, vibrant and interesting place within the heart of the city. We're really close into the heart of the city of Brussels. The building itself, as it is a railway station, it has an abnormal size, I would say, for a everyday building. So the building is 40,000 square meters in footprint. It consists out of 7 halls, 4 smaller ones, and then 3 big ones. The big ones obviously were the place where there were 3 railway tracks. So that was the place where the train came in, and then the smaller pieces were actually where the quays were, so where you just saw the picture of the people. The building is very long and very wide, 270-meter long and wide. So one could wonder if this is actually a public space rather than a building or not. I leave that up to you. So as I said, when we were first called upon, the site had been abandoned for many years. Unfortunately, it was also not very well kept in its state. So here are some pictures of the facades. All the glass that used to be in there, or much of the glass, had been replaced by polycarbonate. The glass that was there was partly broken, etc. So the developer obviously wanted to save the building, and I say save because due to the also in the roof structure being in a bad state, as this is a steel structure. When the rainwater comes in a steel structure, I don't need to explain you what happened. So the client really wanted to keep to fixate the building structure as it is, and then look forward into what could be done within this project. There was at this point, just to keep that story small, but there was at that point a first tender that had been written to do just that. So to make sure that no rainwater came in anymore, to replace what was broken, and to make sure that the building could be sealed off, awaiting further plans of the developer. Now, this sneak preview of what happened afterwards. As you can see, so the building is not a monument. It was not classified according to Belgian legislation as a monument yet. Obviously, this building has a large impact on its surroundings. I'll go to the next slide as well. You can see that it's very prominently visible from the street. So obviously, we needed to keep many of the ornamental elements, like you see here, which nowadays we cannot make anymore because they are much too costly from a time-consuming point of view. Anyway, we needed to keep all that. So the facades have been restored to their old grandeur, I would say. This is the street side. Also on the back side, we did the same. Well, at least our colleagues did the same, and we're not the architect here. This is just a small sneak preview. So what we did at first is look at the big envelope of the building, and then afterwards I will go into the buildings that have been placed inside this Gare Maritime. Here too, and so before the restoration, as I said, the building was in very bad state. The daylight was shielded off by these cheap polycarbonate plates, roof in bad state, and then also the steel structure was rusty in many places. What happened is that so we insulated the entire Gare Maritime. I will come back to that. So we made the whole structure, roofs, windows, and existing walls as far as we could. We insulated it all to a reasonable amount, with a reasonable amount of insulation, and we added, this is one of the main, I would say, elements that we really added to the existing structure, is that we added some daylight openings in the large halls, but also in the smaller ones. You can already see it here, to allow for much more daylight, also going into the office spaces. I will get back to that in a minute. This is just a little sneak preview. So our client at that point, or at some point, decided that within this large structure, and he was also allowed to develop 45,000 square meter of office, and office also including a small amount of commercial space within this entire hall. So which is more or less actually the footprint of the hall could be also developed within the hall. So when we were called upon, as I said, we always strive for fossil free, so a lot of heat pumps in our projects. And in this case, indeed, we had a geothermal installation installed. A total of 22 heat pumps are installed. I will show you how that works in a minute, all connected to a geothermal heating and cooling network. And as we are fossil free, using PV panels, photovoltaic panels on the roof, as well as you can see here in the south facade, will allow us to compensate the energy consumption, at least on a yearly basis, of course, will allow us to compensate our electricity consumption to a large extent, such a large extent that this project, not officially, but probably will be in an energy neutral building with not, I mean, it's not yet, it has not yet been confirmed officially. That's what I'm saying. So, but it will be for sure. Anyway, how did we come to this, or how did this work? So when we were called upon, there was no architect at that point. So that is a very strange, well, not a classic approach, at least of our client. So there was no architect, there was no real design. So what we did is we made a number of simulations to develop an approach for the large building envelope. I will not go into too much detail, but maybe just briefly. It's a 3x2 matrix here. So we had 3 ideas to do the ventilation of the building. Those are the lines. So in the first line, actually, the idea was that the large hall, because that was the big question, of course, what can we do with this large open area that will not be part of the working areas of the building? What can we do with it? What comfort can we get in it? So first idea is that we don't do anything with it. It's not climatized at all, and there is no ventilation going on or anything. The second idea was that, okay, maybe we can have the foul air, which is not that foul, but we can have the foul air of the buildings, the blocks inside, which was obviously the idea. Have that air go through the large hall and then extract it, for example, somewhere on top or centrally. Main goal was to have a airstream of lower temperature in summer and a bit higher temperature in winter to somehow have some impact on the internal temperature in the hall. And then the third one was the full climatization of the hall, mainly or only actually heating. Cooling of this hall is absolutely impossible from a financial point of view, at least. That is just unrealistic. And then in the columns, I will go fast, but the first one, the idea was to have only the roof insulated a little bit, and then there where we would develop something inside this big structure, it would be insulated. The second one is the whole hall insulated to a reasonable extent. This reasonable extent for the Belgian people is actually the rules for new build structures, but just complying. A third idea was to have it insulated thoroughly with passive insulation levels. And then the fourth one was a bit special, in which we really looked into not insulating the hall in any way and having the blocks insulated very much. What was important to our client, I think multiple things, but the main 2 things were that in the hall, so in the large open space, our client wanted to have the possibility to do many things, like for example, he said, if I want to do a fair here, or if I want to do a display of maybe have the auto car show, for example, I should be able to do it. So that's one thing. So the temperature in this large hall should at least be reasonably okay, or for visitors. And secondly, as the architect was not known at this point, it was also very important that we looked into within our scenarios, that we looked within the possibility of having this architect be able to design as unrestricted as possible. So if our proposals would restrict the design of the architect very much, then that would have been a worse proposal. I will go briefly. Heating of the hall, when we simulated that, it was dramatic. So even within the, if we did the passive insulation levels, still the amount of energy that would be needed is gigantic. So that was discarded right away. As the hull is unheated, obviously the extreme large insulation levels were not needed. The impact was very small. And from a monumental, let's say, point of view, a heritage point of view, I'm sorry, that was also a very bad idea. Then if we insulate the blocks very much from the hull, it actually had a negative impact on the amount of cooling that was required within the blocks, because the blocks, we call them the blocks, but the little buildings or whatever development was going to happen. It's always a bit, during the year, it's mostly a bit hotter than outside. So insulating more actually has a rather negative impact. So that was discarded. Yeah, this channeling of air was a nice idea, but the impact, the volume of the hull is that gigantic. So this was also become an interesting option. And anyway, so in the end, we ended up with the idea that they had in the beginning, and then the idea of insulating the hull as a whole, and mainly due to the impact of insulating the hull as a whole on the temperature in summer and winter of this this big volume. It was chosen to not go with the idea that they first had, but to go with the idea of insulating the entire thing. So I'm talking of I think it's 14 centimeters of insulation on the roof, double glazing instead of a simple polycarbonate. Or so it was a large investment, but the client was convinced. I already. This was not the only simulation we made. We made 3 of them. The second one I will also briefly show. It was very important and had a large impact on the final result. Is, as I already said, these large daylight openings in the big spans. So they are there for daylight, and then so I remember back in the day I needed to ask for about 600 square meter of them for natural ventilation as well, because the big hall is then. It has been decided that it is not climatized. So for in summer regime, we needed large openings in the roof as well as reasonable amount of openings on ground level at the entrances of the site, so that we have a natural ventilation flow in summertime. So I asked for 600 square meters and I got more than 2,000 because my colleagues of the fire department needed it to be able to have this large hall also in case of fire, smoke, and smoke-free. And then, as I said, we also added a number of daylight openings in the smaller, they're not that small, but in the smaller sections of the building to allow for daylight to enter from this side, as well as have these real gardens. I call them real, so they're not just some greenwashing, some real gardens within the gar. This is maybe, as I said, one of the interesting results of the simulation. You can see here in blue, if it's visible, you can see here in blue outside temperatures in a standard meteorological year in Brussels. And then I presented it this way also to the client, as we don't do any climatization, then this is actually the distribution of temperatures that one can expect in the large hallway on ground level, in the large, so here, where these people are, on ground level. With a minimum temperature of, let's say, 8, 9, maybe 10 degrees. So that was conceived as okay for what was intended to happen in the hallway. And obviously with also a big, large chunk of temperatures around 2021, these are temperatures that are actually, that would have been much higher if we didn't have a natural ventilation system. So the client was happy with this, and we went forward on that. The design then in the end is this. So within the large Gare Maritime, there are 10 volumes, 10 office buildings, I would say, with some, as I said, some small commercial elements. A little view on the central part. So what is important in the design of what the main idea is that all functions are on the side. So there is a very large open space which can house almost anything the client would wish. And this is then the result. So as you can see, it's a very large open area with the greenery on the side. I will not go too much in detail here, but so the blocks that are housed within the Gare Maritime are 4 stories, and so a ground floor and 3 stories, and they have office spaces, especially on the first, second, and third story. I think these are probably some of the nicest office spaces you can get in the center of Brussels. They have a magnificent view, and are located in the old structure. And on top, as I said, some commercial. Okay, I will go a bit to the technical part. What did we do for climatization? As we wanted to use the heat pump, of course, as a main or as the only the provider of heat and cold. We went for climatized ceilings as much as we could, with which I mean that we put the climatized ceilings in all floor slabs, new floor slabs. The top, of course, that was, well, of course, it was from a heritage point of view, not reasonably doable to put climatized ceilings here on top. So there we chose to use fan-powered convectors on the side, which you can see here in the white. The ducts are all on the raised floor. Voila. And then what we added as well is in the air handling unit, we use adiabatic cooling, indirect adiabatic cooling, which sprays water in the foul airstream, cooling it down, and then this cold can be used in the fresh air stream to have an additional supply of cold. As for heating and cooling, we have chosen to use a geothermal field. The geothermal field is an open one in this case. It's doable in Brussels. We had done it already in the top layer, which is depicted here. It's called the sable, so in the sandy layer on top. The flow rates there, however, are not gigantic. And in this project, it was the first project in which we drilled a bit deeper, literally, and is a matter of speech, that we went further and we drilled. I think there's actually so we made our boreholes up until the rock. This is in Brussels. This is about 100 meters deep. So we went much deeper than before, but it allows us to have a flow rate, a capacity that could be up to 7 times higher. In this case, it was more or less 3 times higher in average than the top layers. This was a first in Brussels, so we also had had to go around, ask permissions left and right, but yeah, it was quite. It was a good. In the end, it was a good solution. Boreholes are located within the Gare Maritime, which is of course possible with a building of this size, also in height. Yeah, the picture is not entirely right. We have 4 borehole duos. So we have 10 boreholes. They are located in between the building blocks. They are then coupled through just a cold water grid. So this is water extracted from the ground. Everything is then collected within a smaller building here on the side, is then redistributed. So this is very dark red and less dark red, sorry. This is very dark. It is not heated yet, so this is just still water. But here we have a heat exchanger, so the red water is not the groundwater anymore. And then within all the buildings, there are, for the bigger ones, so one building block is a little over 3,000 square meters. Every building block has 2 heat pumps. The small buildings here have 1. So then we get to 22 heat pumps for this entire project. And as I said, with the 17,000 square meter of PV on the roof, which equals 3.4 megawatts. Obviously, this is an exceptional project. You cannot do this everywhere, but here there was the option to do it. So our client was very interested. I'm sure we will compensate largely for the consumption of the heat pumps and the climatization within this project. So voila, I thank you very much for your attention, and I'm happy to answer any questions you might have.
So, well, thanks a lot, Thomas, for your presentation. If any of you in the audience is ever in Brussels, I invite you to visit Gare Maritime. It's an outstanding building. So now, despite the great presentation, it's time we move on to the next one. And now we will present, he will present, Anders Zittelund will present the Decarb Industry Award-winning project. Anders is the leading energy consultant and chief advisor in energy planning at Ramboll, and he is widely known as the one who invented modern energy planning. He has more than 40 years of experience in his back, and he has been part of numerous energy master plans and district energy plans in Denmark, which all have been implemented. So Thomas, so Anders, whenever you're ready, please go ahead, share your presentation.
I'm ready. Thank you very much. I'll try to share my screen. Can you see my screen?
We do. Could you put it in presentation mode?
Oh, just a moment.
No problem.
Can you see now?
Not yet.
Presentation?
It's not being shared for the moment. I mean, if it's a problem, I can just share it myself. I have it here with me. But now it seems like we can see your presentation, but not in presentation mode yet. Let's see, try.
Can you see now?
Now it's perfect. Thanks a lot.
Thanks a lot. Yeah, well, it's
Good luck.
well, yes. But as you can see, I'm actually presenting on behalf of Tomby Utility, Public Utility. Tomby Utility has been our client for 40 years or more with water and district heating. And one of my latest projects I've been planning is together with Tomby Utility to plan the district cooling system combined with the heating and wastewater. So just to start where we are, because as we say in Denmark, it doesn't make sense for us to look at one building because buildings are in cities, and when you have buildings in cities, it is cost effective to interconnect them with district heating in our climate conditions. And in business area where you have cooling demand, it's obvious to interconnect them and establish district cooling. Tomby is owned by Tomby Forsyning is owned by Tomby municipality, and in Tomby Forsyning we are responsible for water district heating and wastewater treatment, and now also district cooling. And here you see Tomby municipality, and you can see up in the up to the right you have the Energy Central just north of the Copenhagen airport. Here you can see up in the chopper and look at the whole greater Copenhagen. The colored area here is where we have district heating, which actually is growing right now because all the small gas boilers are now converted to district heating. It's a remarkable project which is presented in reports from EU. It's probably the smartest energy system in the capital in the world, because all buildings are connected to the district heating more or less, and we use all the waste heat from the power stations, power generation, no cooling losses from the power generation, and no energy losses from the waste. All waste is utilized, and it's almost CO2 neutral heat. The next step we are coming to now is you can see the wind turbines in the sea, the offshore wind turbines especially. The challenge is now to gradually integrate wind energy in the energy system, and therefore, even though we have very cheap heat in Greater Copenhagen, it is now cost effective to start with new heat pumps, especially if the heat pumps can be used for combined heating and cooling. And you can see here to the right, we have where we have Tomby Utility. A closer look at Tomby Utility. The green areas is where we have district heating already. Have had it for 35 years. The blue areas are where we plan district heating right now, and the small houses which are not colored, that might be district heating in the future. But to the right, you see the circle around a business area, a new business district in which all the buildings have a cooling demand because it's very close to the metro station, and this metro station has actually been the reason for developing this area with offices, hotels, and aquarium, all buildings which need cooling demand. You could say efficient public transport and district cooling goes hand in hand. Even a closer look. You can see very close to the metro station, you have these dotted areas. This is where we have the buildings with the cooling demand. And you can see to the right, we have buildings which have been connected already, and some new buildings which are coming will also be connected. Actually, Groundwater has contract with almost all buildings in this area. To the north of this area, you can see the wastewater treatment plant. You can actually see in the southern corner of this area, we have the energy center, the green building with a round chilled water tank. That is where we have the energy plant with the heat pumps. Here you see the building with heat pumps and the chilled water tank, 2,000 cubic meter chilled water tank full of cold water, and the heat pump generating heating and cooling combined production. And you can see some numbers here. And you can also see the network. The big pipe is being pulled under the street here, right in front of you. And you can also see the pipes to the Fairing, our biggest customer. Fairing is new office building in Denmark. Big twin pipes for cooling and small twin pipes for heating in the same trench. I think we go on. Let's go inside because I think you're more interested in the heat pumps, right? Am I right? Here we have the very heat pumps themselves in the building. You can see the biggest heat pumps you can get from Sabre, from the supplier of a heat pump. You can also see the pumps pumping the water around and the control panels. Interesting, the smart integration here is actually you have 5 water circuits. You have one pumping from the tank to the consumers. They make sure that always enough cold water to the consumers from the tank, and they can actually deliver the whole capacity to the whole network from the tank. Another set of pumps pumping water from the cold side of the heat pumps to the tank. Third set of pumps is pumping heat from the warm side of the heat pumps to the district heating system at a temperature of about 75 degrees. And now comes the gimmick here, because what makes this project very interesting is that when there's available capacity, when there's not enough cooling demand, we can actually cool down the wastewater with the heat pumps. The treated wastewater is pumped to the plant, and we cool down the wastewater from 15 degrees to 5 degrees. The wastewater plant do not pay for that. But we can also turn it around and say that we extract surplus heat from the wastewater. It's free. We don't pay for it. So it's very efficient because we have the heat pumps available already. And finally, the last circuit is not implemented yet, but will be in future when demand grows, namely groundwater. ACES. So we have an ACES system here. The whole plant is planned for ACES, but we will not invest in it before we need more capacity. So that was a very short presentation of the synergies. We could also say, what about the power system? What is the synergy with the power system? Yes, of course there is, because we have the chilled water tank. The chilled water tank means that right now, today, we have small cooling demand, so we can generate all the cooling in 2 night hours when the electricity price is 0. Because in daytime, electricity price is very large these days, have been previous weeks. So if you had heat pumps in the buildings without the chilled water tanks, you would have had to generate the cooling in hours with high prices. We generate only cooling when prices are low. About the wastewater, if the electricity prices are above a certain level, we will not use heat from the wastewater, because then we cannot compete with the cheap heat from the big power plants, big CHP plants. But when prices are modest or low, it's more cost effective to use this wind-based electricity to generate heat and to replace heat from the cheapest combined heat and power plants. And this competition takes place because we have a big heat market for generating heat in Greater Copenhagen. We try to avoid using more expensive units when we have cheaper units available during the day, during a few days, because we have a lot of heat storage tanks which can level this production. So we can also say that 5-6 megawatt of heat is a little drop in the ocean in Greater Copenhagen, but We will have many plants of this size here in Greater Copenhagen, producing combined heating and cooling and generating heat. And here we use ambient heat from wastewater. If we had not wastewater, it could have been a data center. If neither data center or wastewater, it could have been drain water or at least seawater, or if it air, if that was the poorest solution. Air to water is the poorest solution because the air is cold in winter when we need heat. Just to summarize the project, total investments 10 million euro, and it has been according to the budget. The benefits for the whole society of Denmark, including consumers and cooling company and heating company and all, is about 15 million euro. It's a net present value based on 40% discount rate. So one of the other interesting things here is that how to get started with this project, how to get financed. Normally we finance 100% of all district heating investments with loans. Here with district cooling, we're not allowed to do that, but the consumers, the first consumers said, okay, we have to invest in so much money in our individual chiller plants with seawater cooling and whatever. But if we can get district cooling, we can pay almost the same, but less, so that we get the district cooling cheaper. It's a big upfront payment. That's an upfront payment has been very important for the project here to get started. To go to the bank and say, we have already the biggest consumers and they have paid so many millions, and therefore the bank will be happy to lend us the rest at a low interest rate, because that's important that the banks compete to offer low interest rates. Here in the last slide here, we just show principle for politicians, especially how all this interacts. You can see to the right, we have all the buildings in Tornby. Some of them have district cooling and have heating and cooling demand. You can see they can have a cafe on the rooftop because there's no noisy chillers on the rooftop. Some buildings for apartment buildings and have only heat demand, no cooling demand. The funny building you see, that's actually the aquarium, the Blue Planet, very nice building. It is not connected yet because it has seawater cooling, which has been very, very difficult for them. It cost a lot of money and make a lot of trouble. And we are sure they will connect to the district cooling soon, because they realize that then they can save space and they can save maintenance costs on the existing facilities. You see the wastewater treatment plant, wastewater from all the buildings going to the plant being cleaned, and then before it is let out to the sea, we just pump into the energy plant. And the energy plant, you can see, has a heat pump, combined heating and cooling, and the chilled water tank. But at the groundwater below, with warm well and a cold well. Up to the left, you see just one CSP plant and one heat storage tank. But that's, of course, just to illustrate the combination, because in reality, the district heating system to the left is 100 times bigger, cover whole Greater Copenhagen with many waste incinerator plants and big power plants and a lot of other plants which optimize the heat production. So our heat pump takes part in this optimization. Just to show for political reasons, we see the wind turbines. Wind turbines, that's a power market where the CSP plants take part in the power market. Wind turbines take part, and the heat pump benefit from this market, benefit from the fluctuating electricity prices. So I think that was all for now. I can say that I'm sitting here in Hasmik's office. Hasmik is chief engineer of district heating in Tornby and district cooling, and behind us, we can see the energy plant outside the window. So we are ready to answer questions. I can answer for the planning, and Hasmik can answer how it is in the daily life with heat pump. So we will say thank you very much from here.
Thanks a lot, Anders. Thanks a lot, Hasmik, for being here today. We are looking forward to ask more questions on your interesting project. But now it's time we move on to the last presentation of today. So introducing the next generation heat pump winning project, we have with us Tuomo Niemela. Tuomo is the Department Director of Energy Efficient Projects at Groundwater. He's a specialist in energy, life cycle, and renewable energy consultancy. His specialty is mainly the renovation and retrofitting of existing buildings and the optimization of cost-effective energy performance and low carbon emission solutions, including modern heat pump systems and other renewable energy technologies. So Tuomo, whenever you're ready, the floor is yours.
Thank you. So let's get right on to the presentation. I will share my screen. Okay. Okay, I think now it's showing correctly.
Yes.
Perfect. Yeah, so the final presentation of today. So let's get right onto this energy recycling system for the grocery stores owned by Kesko PLC or Kesko Oyj, Finnish grocery store company, one of the largest companies in Finland actually. They are owning hundreds of properties, and majority of the properties are these grocery stores where we get our daily food and other services. So the brief summary of the project. Basically, we developed this new innovative energy recycling system for Kesko, and the main goal of this development project was to develop an energy recycling system in order to get these grocery store properties almost emission-free and basically carbon neutral. And Kesko has stated that they want to be carbon neutral as fast as possible with their properties, but by the latest of 2030. But I think we can exceed those targets. At least it seems so right now. And basically, the main idea is to reduce the heating energy consumption or heating energy demand of these properties using this new energy recycling system. And according to the preliminary estimations and measured data that we have gotten from these buildings, it seems that 80 to 95% reduction has been achieved or is possible to be achieved with this new system. And I'm representing Groundwater, but we have not developed this alone. So I'm actually representing 4 different companies involved in this project. So Groundwater, we are the actual designer. Then we have Tomal and Senera, the contractor, doing the installations and implementation of the projects. Then Gepwell, who is the technology supplier, providing or delivering the heat pump units, heat storage tanks or accumulator tanks and other equipment. And then of course the client Kesko. So basically 4 different parties participated in this development project. A little bit of about the technical solution. So basically these grocery stores in Finland, in Nordic countries and basically all over the world, they are quite energy intensive due to the fact that you need to cool the groceries and the refrigeration and cooling demand is quite high. So there is a lot of potential to recycle the heat back to heating, especially in Nordic countries where we also have quite extensive heat demand due to the cold climate. And the basic principle, I will demonstrate this a little bit better, but the basic principle is to recycle all possible or all potential waste heat flows back to the grocery store and utilize them for heating of the property. And the main heat flows are the condensate heat coming from the refrigeration and cooling systems of the property. And then in some cases, these larger grocery stores or hypermarkets also exhaust air of the ventilation systems. We have some air handling units without any proper heat recovery, so we can collect the heat using this heat pump system. And the main idea is, of course, to renovate the existing refrigeration systems utilizing R404A refrigerant to CO2-based refrigeration systems. So we are also renovating the refrigeration system and then also implementing this energy recycling system at the same time. And basically in the future, this energy recycling system, it can also be extended to utilize different energy sources coming outside of the building. So boreholes, ground source heat pump system utilization, or air to water heat pump solutions, so that we can produce even more heat to the system or to the building with this system. But the main heat source is main heat sources are the waste heat flows of the property that we want to utilize. A few words about the actual project implementation. We talk about comprehensive renovation. So basically these projects, they have been divided into two phases. We have the project planning phase and the actual implementation and monitoring phase. And the project planning phase, we want to determine the mandatory repairs and renovations. So we are doing condition studies or surveys and also energy audits. And then we combine the mandatory repairs that we have to do, major or deep renovations that we have to carry out anyways, and we combine them with the energy efficiency improvement project. Then we move on to the implementation planning and the cooperation with the aforementioned parties. And then we carry out the project, make sure that the quality is excellent, and then move on to the monitoring phase, where we assure the quality is top-notch and the development and operations of the concept that we want to continuously improve the actual concept. So you can make a summary that we gather the initial information, then we go through the project planning, implementation planning, installations, utilizing cooperation, and then continuous development of the project so that it's more cost effective, more energy efficient, and better suited for also future machine learning or artificial intelligence applications that can be utilized. Here is a picture of the project. So basically, like it's here shown here, we have the heart of the system is the heat pump system, utilizing basically normal heat pump units, and we are gathering energy from different energy sources. The main energy source is the condensate heat coming out from the refrigeration system, but then, like I mentioned, we can also take condensed heat coming from the regular cooling of the property, and in some cases from the waste heat of exhaust air. And this is basically an option that we can extend this system to utilize external heat sources in the future. So we have not yet implemented any borehole solutions, but this can be extended, or we can extend the system to utilize boreholes or air to water heat pump technologies in the future. Then we are producing heat to heat distribution center, where it's divided into different heating networks of the property. So ventilation heating, space heating, and of course heating of domestic hot water as well. And with this system, even without the boreholes, we can get as high as 95% coverage of heating energy just utilizing this system. So the additional heating energy requirement or need is quite low. One key aspect of the project is this pre-manufacturing or prefabrication. We basically fabricate all these components in the factory, and then we just deliver these modules to the property. So this is an example from one project. Because these are renovation projects, we have limited amount of technical space. The technical spaces are typically located in the basements and spaces like this. So we want to carefully prefabricate everything and then deliver the modules into the technical room. And the installation time on site is as low as 2 or 3 days. So basically we are just connecting these pipes on the site, and everything else is pre-manufactured in the factory. So it's quite fast installation on site. And in previous generation projects, we did all the installation on site, and it might took 2 to 3, even up to 4 weeks to get it up and running. And of course, the possibility for errors is quite high as well if we are doing a lot of installation on site. Another picture from heat recovery module. So this is, we have the circulation pumps expansion vessels and the heat storage tank or heat recovery tank, they have all been pre-manufactured and then just delivered to the refrigeration room where the actual CO2-based refrigeration units are also located. So we are utilizing module-based pre-manufacturing and utilizing this to replicate or copy it from one property to another in order to maximize cost effectiveness as well. Few pictures of the installations. So this is what it looks like in the or on site in the property. These Gapewell heat pump units are located here, and some pipes and heat recovery tanks, cooling tanks, and other equipment. So there's quite a bit of technology involved in this concept, but we have, like I said, we have minimized the potential or possibility for errors by utilizing this careful designing and pre-manufacturing or prefabrication. A little bit about the potential and the objectives of this project in general. So basically, this is the energy saving potential in Kesko's grocery stores in Finland. So these city markets, they are actually hypermarkets, so big grocery stores or the largest ones, approximately 65 are going to be carried out utilizing this concept. Then these medium-sized grocery stores, supermarkets, 130, and some cash and carry outlets as well. So over 200 properties will be conducted using this concept with property-based fine-tunements. And then, of course, some smaller K markets. There's actually 600 small-scale grocery stores in Finland. So I think we are utilizing a little bit lighter concept for these projects and try to conduct these as well. Then the energy saving potential of the whole property portfolio. So heating energy over 100 gigawatt hours and electrical energy about 20 gigawatt hours. So the overall delivered energy of the portfolio we try to reduce up to 125 gigawatt hours. And for Finland or country as small as Finland, this is quite high energy saving potential. Also considering the whole Finnish building scene or building sector. And the target of Kesko is 105. So we try to exceed their ambitious target by approximately 20% with these projects. So their actual target is 105, but we aim for 125. This basically shows an average project size, what is going to happen in these grocery stores. So at the moment, approximately 30 projects have been carried out. 15 are in the planning phase, approximately. And like I mentioned, we still have approximately 160 grocery stores to go. And I want to highlight that this kind of concept, it also has a significant international potential so that we can utilize the same kind of concept in many different countries with some country-specific adjustments. But this is quite easy to replicate in other countries as well. But for hypermarkets, average investment is approximately 400,000. And like I mentioned already, we get quite high reductions in the district heating or heating energy consumption of the property, and also some reduction in the electrical energy, regardless that we are installing additional heat pumps, because we are also saving some electrical energy through lighting, more energy efficient refrigeration system, and so on. And average savings using Finnish district heating electrical prices, approximately 30,000 euros in these medium-sized grocery stores, and then these hypermarkets up to 60,000 euros. Some results, of course, we have some further results already, but this is from time before COVID-19, because throughout the COVID-19 period, we haven't been able to use these buildings as they are supposed to be used. For example, that we are using air handling units or ventilation is on 24/7. We are using higher than normal ventilation airflow rates in order to prevent COVID. So the 2019 is easier to compare, and of course now 2021 we also get data that what is the actual saving potential, so that it can be referenced or compared to the original situation before the COVID-19. But like I already mentioned, quite high saving potential, and the results look promising in these markets. A few words about the advantages. Like I already mentioned, the scalability, replicability. This can be utilized also in other countries than Finland or Scandinavian countries, and can also be used in other building types, such as offices, commercial buildings, industrial properties, and so on. And utilizing this prefabrication or pre-manufacturing, we have seen that this is quite cost effective, because we can replicate or use the same concept over and over again. So it's quite cost effective in the larger scale. And fast installation time on site, minimum of 2 or 3 days, less errors. And of course, energy efficiency. The energy performance is quite high using this concept, and all waste heat flows are utilized maximally. So we are not sacrificing anything. We take the heat from all the possible internal waste heat flows. Of course, remote monitoring, we can utilize preventive maintenance, for example. We are carefully monitoring these, so we have seen improvements in the maintenance sector as well. But of course, some development areas, there is always room for development. Basically, the first one is the refrigerant selection. We are now using R410A refrigerant, and due to the limitations of the F-gas regulation, we need to replace these refrigerants basically during the next 10 years. So this has been, we are aware that we need to do something with this refrigerant, but we are confident that we can handle the F-gas regulations, even though now we are using these R410 refrigerant-based heat pump units. And some replacement refrigerants are, of course, being developed all the time. And in Finland, we have this tax revision. Basically, it's coming, I think, in the beginning of next year. So we can get up to 22 euros per megawatt hour reduction in the overall electricity price. So this opens new doors for different kinds of applications that we can utilize these systems, and it's even more cost effective after this one. It means that we have to be able to use two-way district heating. So we must be able to produce excessive heat energy back to the district heating network, and then we are eligible for the tax revision. Further development can also be implemented in the monitoring of the system. So we can use fully automatic monitoring. Now we are still doing some manual monitoring, even though we are utilizing automatic features, but we can still improve on this. And then, like I already mentioned, machine learning and some artificial intelligence features in the control strategy of the systems, they can be implemented. I think we are quite close of that point that we can use AI-based solutions. And of course, the heat pump technology, it's developing all the time. So I think every 3 or maybe every 5 years, we get basically the next generation heat pump technology available, that are the new heat pumps. They are more energy efficient than the previous ones. So we can also utilize from the general development of the heat pump sector. And finally, what are the possibilities if you consider like city or municipality scale? So basically these grocery stores, they can act as energy production parties or producers of heating energy like any other energy company. So we can produce heat back to the district heating network, grocery stores, industry sector, data centers, and so on. And we can utilize or benefit from these systems. also in a larger scale than only the building. And this kind of market is developing quite fast in Finland. So we already have some major players doing this kind of operation as part of the energy companies, the regular district heating companies. So this is quite large potential also involving the tax revision, like I mentioned. Yeah, I think I have used my time. Thank you everyone for your attention, and a few pictures of these projects in the end. So basically here you can see the final or the installed system, what it looks like in the actual property. So quite a bit of technology, pipes, storage tanks or accumulators, heat pump units, and so on. But for now, we have got quite good results, and everything is still, how do you say, under control, even though we have implemented these in dozens of properties already. And like I mentioned, we are also doing other energy efficiency measures, for example, PV panels for electricity production, renovation of the existing refrigeration systems to CO2-based systems, and these pre-manufacturing. We are trying to maximize the benefits of this in all of our projects. So comprehensive renovation, including other measures than just the heat pump system, even though the energy recycling system is the heart of the project. Yeah, thank you everyone.
Thank you very much, Tuomo, for your presentation. And well, unfortunately, the presentation time is over. However, we have now, like, I would say around 15 minutes for the Q&A session. So if you still have questions that you would like to, if you still have questions that you would like to raise, just I invite you to use the chat and just indicate the name of the speaker. I will start with one of the questions that we have received already on the chat, and it's directed to the project in Tarvi, so it's for you, Anders. And I would like to ask you, well, not me, but Lorraine Devouton. I hope I have pronounced the name accordingly. She was wondering that if for the district heating and cooling in Tarvi, whether you had benefited from support schemes like subsidies.
Yes, we saw the question, and there was no support schemes.
And then whether there was an average, and what's the average customer price for the heat in euros megawatts?
For heating?
Yeah. So what's the average customer's price for the heat in euros megawatts? Like, that's the other question that was raised.
I have it in Danish kroners, about 150 Danish kroners per megawatt. I don't know.
But the total price, would you want it for the one family house, because it's both fixed cost and variable, but for one family house, it's typically 1,500 euro. But we have a high price on gas and oil because of it's taxed, and therefore the market price, or the competitive district heating price, is cheaper than that. But it also means that we can extend district heating to many buildings which would not be competitive for district heating in countries without taxes. So we have a high level of we do a lot to replace the fossil fuels by taxing them, and therefore we open for more expensive solutions, district heating to small houses or heat pumps to small houses. But in general, district heating is competitive in Tampere, and consumers really want to have district heating because it's silent and efficient and just works easily.
Okay, then thanks a lot. I would like to ask a question to Patrick, as he presented first and he was very silent for the last hour. I would like to ask you, like, of course, your project is in the residential area, let's say. So what was the most challenging part of delivering this project to the residential customer?
Yes, interesting question. really for us. It's about getting the tenants and the residents on board with what's planned, because if you can imagine, we might have to drill anything between 16 and 24 boreholes around the property with a drill rig. They're there for sometimes, up to 2 months, drilling down to 200 meters. It makes a lot of mess, and then there's the trenching. And for electrical properties, we then have to bring that into the building. And then inside the properties, because they haven't had a wet heating system, all the piping has to be installed, and it's very disruptive on people, many of whom are old. So we really have to spend a lot of time getting those residents to buy into what we're trying to achieve, and for them to understand that they will get benefits from it directly, as well as the wider benefit in terms of carbon reduction and benefits towards us as an organization. So that can be quite challenging, and you have to keep them on board as you go along. But we did find that because what we're doing has been so unusual and they haven't seen it before, there's a lot of interest in seeing the rigs on site, and whether we were fracking or drilling for oil or whatever was a regular kind of question. But it is a key point, and it's not easy to manage, but it is an essential part of delivering what we delivered.
Okay, so thanks for the answer. Now I would like to ask Thomas. Thomas, you have presented us with several simulations that in Gare Maritime. So I would like to ask you, if you can provide us an example of how, doing this simulation has actually provided, freedom for the architectures to actually work on the design, the redesign of the building.
Yeah, so we actually did 3 simulations. So the thermal one you have seen, or at least seen some results of it. We did the daylight simulation. You have not seen results of the simulation, but you have seen what happened in the roof. And then we did also a building physical simulation, or at least an evaluation of the existing structure and the possibilities or the risks of condensation issues. But maybe you're referring mainly, I think, to the thermal simulation.
Exactly.
Yeah. So if you remember my 12 cases, what we really looked into and what was the basis of then the column number 2 of the insulating of the entire Gare Maritime instead of insulating the blocks inside. The difference was that the U value of the block towards the big hole is in the case now, that the case that has been built and has been selected as the best one. This U value is 1 or 1.1, meaning that the architect could perfectly choose between glass or glazed surfaces, and double glazing, of course, glazed surfaces, transparent surfaces, and opaque ones. And also the opaque ones are not gigantically impactful on the way this block, this building block shows itself towards the big Gare Maritime. So that was also one of the reasons why indeed column number 2 was chosen definitely over column number 4. Because in column number 4 we went with 0.24 or something. I don't remember exactly at heart, but that would have made these blocks very untransparent towards the Gare Maritime. And in the end, this also we did not. It was not specifically our proposal, but then the architect Nutlings Riedijk has selected wooden structures. So completely wooden structures inside the Gare Maritime, and having this combination of glaze and then prefabricated insulated wooden panels made the structure quite simple, actually simple to do, very prefabricated and very fast. So that was luckily, if you had to do it layer by layer with large insulation values again, then that would have taken more time, I think. I hope that's an answer to your question.
Yes, thanks a lot, Thomas. Now I would like to ask a question to Tuomo. You were presenting the energy, this energy recycling concept, in Finland, and you touched upon how that it could actually be replicated in an international level. So I would like to ask you if you could expand a bit on how this replication internationally could be possible.
Yeah, good question. So basically, like the main technology concept, it's actually quite simple. We have the heat pump unit. We are using heat pumps in different countries with the different country specific adjustments or basic principles that how we use, for example, ground source heat pump or air to water or different other heat pump applications. So these this kind of concept, basically we just use the heat pump technology to recycle the possible or potential heat flows located inside the building. And for example, grocery stores, we have grocery stores in Spain, in Germany, in all of the countries. And the main idea of the grocery store is the same, to keep the foods cold, so that we have cold milk, cold cheese, and so on. And the basic principle of the refrigeration system is pretty much the same. We are using CO2 refrigerant-based systems in all the countries, mainly already due to the F-gas regulations. So this heat pump concept, with this kind of implementation, we can quite easily connect it to all similar kind of buildings, regardless of the country. So, of course, if you consider energy recycling system in grocery stores of Germany, for example, or other Central European countries, you need to optimize the capacity and the implementation concept so that it's not an over investment, so that it's cost effective and it's optimally sized or dimensioned according to the specifications of the building, for example, heat demand and the available refrigeration condensate heat that is coming out. So I would say or summarize that country-specific optimization is needed, but it's quite easy to replicate in all the countries with or including grocery stores. But of course, the easiest way is to implement it with the same kind of specifications in the Scandinavia or in the Baltic countries, I would say, because the climate is pretty similar and the technology is pretty similar already, but other countries as well.
Definitely. Thanks a lot for the answer. Now, I would like to ask another question to Anders and to Hasmik, but this time I promise it's not about support schemes. I would like to ask you, like in your project, you briefly mentioned sector coupling. So I would like to ask you whether, like, what would you consider that are the most important sector couplings that took place or that are taking place in this project?
Actually, I would say all of them. First of all, the public transport paved the way for this business area. The district heating was obvious. Sector coupling with buildings, district heating instead of building level installations. The fact that you can make district cooling and combine heating and cooling is a very important sector coupling. The fact that you can establish a chilled water tank so that the heat pump can operate with the electricity market is a fantastic sector coupling to electricity. And already now we have in the heat market a complete sector coupling with electricity, because all the combined heat and power plants operate hour by hour, taking into account the electricity market. So this is fantastic. But
And wastewater.
But then comes the wastewater, because it's very difficult to get started with such a project. And the fact that we could use the heat pump available capacity to cool down the wastewater, that was the economic benefits, which really said, yes, we go for it. And then, of course, the groundwater, maybe not so important, but in this case, and right now, but could be in future, because with the groundwater, we avoid generating so much heat in summer when heat is cheap, and instead we have make sure that heat pump has enough to work with, to eat or more or less, as we say, in winter. If the water flow in the wastewater is low, we can supplement with the groundwater. So all couplings, and this may be world record in sector couplings.
Okay, thanks a lot for your answer. Very interesting. So many sector couplings involved in just one project. Yeah. So I would like to get back to Patrick. I asked you about what was the most challenging part of delivering the projects, but
sorry, I forgot one important.
Oh yeah, please go ahead.
Right where we are. We are at a very, some people say, a very nasty place. We will not have it in our backyard, but it is necessary in any city. You need to treat your wastewater. And we are at the wastewater treatment plant where here, right now,
Oh,
it's not so smelly because we have covered the roof. Hasmic has covered the roof with some plastic and sucks out the air. And the chimney you can see in the back is not for boiler, but for sucking out the cleaned air. Because of this clean wastewater treatment plant, you could develop this business district nearby, very nearby. And where should we put the energy plant? Space is very expensive. We have just a little corner of the wastewater treatment plant where there was space enough for the chilled water tank and the energy plant.
okay, thanks a lot.
Saving 2 million euro.
Thanks a lot, Anders, for the answer. And as I was saying, I'm going back to Patrick. I mentioned, I asked about the challenging part, but I would like to know whether you can provide me some information about which actions you actually took to convince or to actually allow residents to see the heat pump solution as a good option.
Yes, I think starting at our pilot project, we actually, sorry, that's my dog in the background.
No problem.
We took some of the tenants to see another scheme that had already been completed elsewhere. And we followed that on with a series of group meetings at the properties, and then individual one-to-one meetings where we described exactly how it's going to work. They got the choice where the radiators would go, and they got an understanding of how the system would need to operate and how they would interact with it. And I think one of the key things is convincing them that there are going to be real measurable benefits for them in terms of how it's used. Sometimes that's as much about comfort as it is about cost, because a lot of these tenants are older, but cost was also an important element. And we did that through having our own specialist, what we call tenant liaison officers, who this is their job. But also we involved the contractor and the makers of the technology directly alongside us in each of those discussions. And I think a lot of it's just about time and putting the effort in to actually take people with you. It's not easy, but it seems to have worked. It's one of the things I would say though is because we were taking out storage heating, this was an easy door to push at because the tenants really did not like storage heating. And so given another option, they would probably take it. It gets more challenging when you're taking gas out, people's familiarity with gas and the instantaneous heat and that gas provides. But again, we've managed, we're in the middle of the major project doing that at the moment. And the tenants have, again, been very cooperative. And the bigger thing here was the safety issue, because these are tower blocks. And for those of you familiar with the Grenfell disaster in London, where 80 odd people were killed because of a fire, and gas was a major part of that, as well as the cladding. And there's a strong awareness of that. So obviously with heat pumps, there's nothing combustible going on in the property, and it's a much safer solution. So we've used that as well.
Okay. Thanks a lot, Patrick. And now I think we have time for one more question.
Sorry, could we leave now because we have another?
Yes, sure. Thanks a lot for being here with us today for your interesting presentations. So I invite the audience, if you have more questions for Anders and for Hasmic, I will share the presentations. Their contact details are there. Therefore, you can contact them directly. And thanks a lot, Anders and Hasmic, for being here today.
And thank you very much to all our presenters for interesting presentations. Thank you very much for inviting us.
Thank you. So I think we have time for one more question. So I would like to ask you, Thomas, in Gard Maritim and around, there's several buildings there's several buildings on the same site. And I would like to ask you whether there could be an advantage of linking the buildings together, system-wise.
Yes, the answer is simple, yes. Well, we are not the engineering company of all the buildings on the site, unfortunately, maybe, but the site is very big. There are right now next to the Gar Maritiem, there are 2 buildings that use geothermal energy, and therefore heat pumps for their heating and cooling passively. They don't go as deep as us, so they stay in the top layer of the sandy top layer. But that doesn't really matter. Coupling them, would that be interesting? Yes, for sure. However, the buildings that have the geothermal solution right now are mainly office buildings. The buildings that don't have the geothermal solution yet would be more worth coupling. So one of them will be an elderly care home, or it's not really a full home, but it's a where elderly people can live. They can get some help living by themselves, but nevertheless, we'll use quite a lot of sanitary hot water. So we looked into that link. It has not been made yet from the Gar Maritiem towards the other building, but it is ready to do so. So we, for sure, we do intend to have different building types linked together. It just still needs to happen, but it's something we do on other sites for sure. As I said, if you have a combined heating and cooling demand at one time frame, then of course your energy efficiency goes up gigantically. So yeah, the answer is always yes. You just need to look at the distance, of course, whether it's doable. And in this case, it's ready to do so.
Okay, great. Thanks a lot for the answer. As I said, we are running out of time. So I'm going to take this chance to just present one more thing before leaving. On the 18th of November, EHPA is organizing the second matchmaking event of the year. This time it will be an event very interesting, focused on walking walking you through like the different funding of offers that exists in the renewable heating and cooling sector. Of course, it's a matchmaking event. We won't use Zoom. We will use a super nice platform called Remo, in which I don't know if you can see in the picture quite fine, but you can actually sit on the chairs and talk with the people that you are sitting with on the table. So if you're interested in that, I encourage you to scan the QR code that you have here and register. I'm sure it's going to be very, very interesting. Then, of course, I have to take this opportunity to if you want to be posted with all the HPA events and anything that we are working on, to follow us on social media, subscribe to our newsletter, check our website. All the links, you can find them by scanning the QR code. You have like all the lists. So everything that you would ever need from EHPA is there. Then, of course, I want to thank the speakers for being here today and for the very interesting presentations. Again, as I said before, I'm going to share the presentations maybe probably tomorrow, if not by Monday. So in case you have any doubts that haven't been solved today, you can contact them directly. I'm very sure that they will be very glad to answer you and have a conversation with you, to provide all the information that you will ever need. And of course, I will also like to thank, before leaving, the Great Forgotten. It's just today we have 4 winners, but as I mentioned at the beginning, we had more than 200 submissions over these last 10 years. Therefore, this heat pump award wouldn't be possible without all these great examples of heat pump applications that we are receiving. So of course, I want to invite you, in case you have a great project, to present it to the Heat Pump Award. We will be super glad to read it and get to know it. And thanks a lot. And I wish you a great lunch break. Bye-bye.